Hi, we're going to talk about using geometric series for some real-life applications, and what we're going to talk about is how to use them to write fractions. Let's talk about how to write decimals as fractions in general. So what we do is we're going to look at 1.3, and then the process is very simple. We're going to write these numbers without the decimal point, all of them. And on the bottom, we're going to write 1 followed by as many zeros as you have decimal places here. So there is only one number to the right of the decimal point, so we're going to write 1, 0. 13 over 10, it does not simplify, and that's it. Yes, this is as simple as it's done. 2.5. So we're going to write 25 over, we're going to have one decimal place here, so 1, 0. This fraction can be simplified. They both divide by 5, and it's going to be 5 over 2. So that's 5 halves. 0.95. Alright, so here we're going to do 95 over 100. We suspect these can be simplified, right? Because they probably, they for sure both divide by 5. So if you divide both by 5, you're going to get 19 over 20. And then 0.124, so we're going to write all the digits. We don't need to write 0 here, because if we put 0 here, it's going to be meaningless. So how many zeros are we going to write after 1 here? So we have 1, 2, 3 digits, right? So we're going to write 1 followed by 3 zeros. So it's 124 over 1000. And 124 over 1000 can simplify. And it simplifies to 31 over 250 because both numbers divide by 4. And this is how it's done. The question is, if this keeps on going, not fractions, I'm sorry, not decimals like this, but if we look at 0.3 repeating, so how can we write that? Can we use the same approach? Well, let's try. So if we look at that as 0.3, we can write it as 3 over 10, right? But that's not 0.3 repeating. If you do 0.33, that's 33 over 100. It's still not the same number. It's more accurate, but not the same. And the problem we have, since it's a repeating process, we can't really do it the same way. So what do? Repeating decimals are actually convergent geometric series, and we can use that to write them as fractions. Let's go back to this 0.3 repeating and try to do that. So 0.3 repeating is what? It's 0.333 that keeps on going. That is actually going to be, you can rewrite that as 0.3 plus 0.03 plus 0.003 and so on and so forth. And if you write each one of them as a fraction, you're going to get 3 tenths plus 3 hundredths plus 3 thousandths plus so on and so forth. So this is a geometric series. The first term is 3 over 10. The common ratio is to go from 3 over 10 to 3 over 100. If you divide these two numbers, it's going to give you 1/10. The common ratio here is less than 1, which means, well, the absolute value of the common ratio is less than 1, which means it's convergent. And the formula that we should know from the other lesson, it's going to be the first term, which is 3 over 10, over 1 minus the common ratio, which is going to be 3 over 10 divided by 9 over 10, and it's going to simplify to 3 over 9, which actually simplifies to 1/3, and that should be a familiar fraction because that's exactly what it is. So we will use this formula over here that is going to help us write any repeating decimal as a fraction. Absolutely any. All you need to do is write that as a geometric series, figure out the first term and the common ratio, and then just do it. So let's try to do it with 0.4 repeating. So 0.4 can be written as 0.4 plus 0.04 plus 0.004 plus 0.0004 plus so on and so forth, and this goes on forever. So this is our first term. We actually can write it as as a fraction, so it's 4 over 10, which is going to simplify to 2/5. What's the common ratio here? If you take 0.04 and divide it by 0.4 and you actually divide them, you are going to get 0.1 or simply 1/10. And then to calculate the fraction, we are going to set it up. So 2/5 divided by 1 minus 1/10, which is 2/5 divided by 9/5. And if you simplify that, that's going to become 2 9ths. You actually plug in 2 9ths in the calculator, divide 2 by 9, you will get 0.4 repeating. Let's take a look at example 2. Example 2 is slightly different because the repetition here is every 2 digits. What we have here is 0.242424 and so on. So as an arithmetic series, we can write it as 0.24 plus 0.0024. Notice we shift by 2 digits, plus 0.00024. Right? So our first term is going to be 0.24, which is 24 divided by 100. Both can be divided by 4. So it's going to be 6 over 25. The common ratio here, if you take you can use the decimal form here, and that's going to give you 0.01 or 1 over 100. So we got the common ratio, you got the first term. So 24 over, I'm sorry, we're not using 24, we're using 6 over 25. We use the simplified form. You can actually use this too, and you will get the same answer. 1 minus 1 over 100. So it's going to be 6 over 25 divided by 1 minus 100 is 99 over 100. And that's a little bit more challenging, but I think it's going to give us 24 over 99. Again, if you use a calculator and divide 24 by 99, I just did it here, and you can see it is 0.242424 repeating. Okay, got a couple more. So what happens if the first digit to the left of the decimal point is not 0? So we're going to write that as two things. 2 plus 0.12 repeating. So we're going to get to 2 in the moment. So for 0.12 repeating, we're going to write it as 0.12 plus 0.0012 plus 0.000012 plus etc. Our first term is 12 over 100, which I'm actually going to show you. I'm going to leave it like that for now. Our common ratio here is going to be 1 over 100, because if you divide 0.0012 by 0.12, it's going to give you 0.01, which is 1/100th. And we set this up, 12 over 100 divided by 1 minus 1 over 100, which is going to give you 12 over 100 divided by 99 over 100. Which is going to give us 12 over 99. They can be both divided by 3, which is going to give us 4 over 33. But we need to remember here that we're not done, because we have 2 here that we need to make sure that we address. So this here is equal to 0.12 repeating. So to finish our problem, we need to do 2 plus this fraction. And we're going to use the rules that we hopefully know. So 2 written as a fraction with 33 on the bottom, write it as 2 over 1 times 33 times 33, 66 over 33 plus 4 over 33. It's going to give us 70 over 33. This is our answer. And if you divide this using a calculator, 70 divided by 33, as you can see, it is 2.12121212. Last number. The only difference here is you have 3 digits repeating. We do have 1, we already know how to do that. So it's 1 plus 0.258 repeating. So with 3 digits repeating, you're going to enter 3 zeros, right? So 0.258 repeating can be written as 0.258 plus 0.000258 plus 0.000000258 plus etc. So the first term is 258 divided by 1000, 3 digits. The common ratio here, you can divide this number by this number, you're going to see that it's going to be 1 over 1000, because you're going to end up shifting it 3 digits. So to write that as a decimal, as a fraction, 258 over 1000 over 1 minus 1 over 1000, which is going to give us 258 over 1000 over 999 over 1000. It's 258 over 999, which I believe can be both divided by 3. So it is going to simplify to 86 over 333. But remember, this is just that. We also have 1 that we need to add to it. So we do 1 plus 86 over 333. So 333 over 333, that's what 1's going to be, plus 86 over 333. And we add them together. 333 plus 86 is 419. So it is going to be 419 over 333. And that's as simple as it is. If you have any questions, please put them in comments. Hope this helps.